So hello student, this is our lecture 6 of vectors. In this lecture, we are going to see these topics. First, symmetrical form of line. Even though we have studied this previously, we are going to look at it again. Then we will see shortest distance between two lines. Okay, we are going to talk about distance between two lines too. Then we will see what is plane, what is the equation of plane, and what are the parameters of plane. Okay, then we will see distance of a point from a plane. These four topics are majorly we are going to cover today. Okay, but before that, we are going to see the questions that I have given you in previous lectures. Okay, so first is OA cross OB is given, OB cross OC is given, OC cross OA is given, and we have to find CB cross CA. So what we can do? First we can write CB cross CA. Then you can use position vector of these. So CB will be OB minus OC cross and CA will be OA minus OC. So we are normally going to use cross product. So OB cross OA, OB cross OA, OB cross OA minus OC cross OA. Okay, then OB minus OB cross OC, and then in the end you will write minus OC cross minus OC, that will be plus OC cross OC. We have already seen that if two vectors are parallel, their cross vector is 0. Why? The angle between those vectors will be either 0 or pi, and sine 0 and sine pi will be 0. Then we have found OB cross OA, OC cross OA, and OB cross OC. What is given? OA cross OB is given. We have written OB cross OA. Okay, so we can write it like this: minus OA cross OB. Then we can write this one: minus OB cross OC minus OC cross OA. And what is given in the question? Let's see. Wait. What is given in the question? Let's see. It is given that OA cross OB 101 minus 101. Okay. So we can take minus outside. What we can write? 101. Then minus 1 plus minus 1, 1, 0 plus final thing, that is OC cross OA. Yes, we have to find OC cross OA. So 0, 1, 2. 0, 1 and 2. Okay. So minus we have taken outside. What will be the sum? This will be 1 minus 1, 0. So this will be 0. Then 0, 1 and 1. This will be 2. And then 1, 0, 2. So this will be 3. Okay. So what we got? We got 0, minus 2 and minus 3. And what is this? This is the question asked. CB cross CA. This is the value of CB cross CA. So this was simple application of cross product. Okay. Then next question. It is on the next page. Next question was, prove that 3 points with the position vector A plus B, A minus B, and A plus lambda B are collinear for every lambda belongs to R. Okay. First of all, let's assume these position vector are, let's say vector P is equal to vector A plus vector B, vector Q, vector A minus vector B, and vector R is equal to A plus lambda times vector B. Even though I can do this question by using linear combination theorem, but we have already studied that if three position vectors are collinear, if three PVs, position vectors are collinear, then sum of their cyclic cross product must be 0. So P cross Q plus Q cross R plus R cross P, that must be 0. Okay, let's see. We can find P cross Q. So P cross Q will be A plus B cross A minus B. So this will be A plus B cross A minus B. Okay. So A cross A will be 0. A cross B, that will be minus A cross B. Then again B cross A plus B cross A, and again B cross B will be 0. So this is your equation number 1, let's say. Then Q cross R. Okay, so we can write Q cross R. What is the R? A plus lambda B. So A minus B cross A plus lambda B. So first we are going to use with cross A. So A cross A again 0. And then A cross lambda B. So lambda will be outside. This will be A cross B. Okay. Then minus B cross A. So this will be minus B cross A. And again, when minus B cross lambda times cross B, that will be 0. Why? Because both are parallel vectors. And again, I have already told you that angle between parallel vectors will be 0. Then R cross P. R cross P will be what? That will be vector A plus lambda times vector B cross. What was the P? Vector A plus vector B. So again, use vector A cross vector A, that will be 0. Vector A cross vector B. So vector A cross vector B. I am not simplifying it yet. Okay. So I will be adding those. Then if it needed, I will simplify it. Okay. Then lambda times A. So this will be plus lambda times A cross B. We have lambda here also, right? No. Lambda times A cross B. Lambda times B cross A, not A cross B. B cross A. So this will be lambda times B cross A and lambda times B cross B. So that will be 0. This is your equation number 3. Add all. Add all. If it is coming 0, then it doesn't matter whatever the value of lambda is. It will be always coplanar or collinear. We are studying right now collinear. So these will be always collinear. If they are getting, if after adding we are getting 0. Okay, let's add those. So one is A cross B, B cross A. So B cross A from B cross A. This is cancel. Okay, so this is minus A cross B. So from this, you can cancel out this. Okay, in final step, this is lambda times A cross B. This is lambda times B cross A. We already know that A cross B is equal to minus B cross A. So these are opposite to each other in sign. So this is also cancel. So after adding this, left hand side we are getting P cross Q plus Q cross R plus R cross P. These all are vectors, position vectors. So you have to put vector. And in right hand side we are getting 0. What does that mean? We were studying area in this form also. So if area of a triangle is 0, then all 3 points are collinear. Okay. Okay. One more question I have given to you in the class, that find direction cosines of a line perpendicular to L1 and L2. So I will take yellow marker. Perpendicular to L1 and L2. So first of all, we have to find what is the direction, drs of L1. Drs of L1. Straightforward, whatever the written with the parameter, those are the drs of the line. So lambda के साथ क्या लिखा हुआ है हमारे पास? So that will be 1 minus 2 and 1. Okay. Similarly, drs of L2. Drs of L2 will be this 1, 2, 3. Okay. So if I have to find dr of any line which is perpendicular to the L1 and L2, so drs of vector perpendicular to L1 and L2, that can be given by 1 minus 2, 1 cross 1, 2, 3. Okay. You can also given it by this 1, 2, 3 cross 1 minus 2, 1. Okay. So this will be what? I, J, K. 1 minus 2, 1. 1, 2, 3. And I know you can solve the determinant. So we are going to solve the determinant. I cap minus 6 minus 2. So this will be minus 8. Again, we are going to try J. So this will be 3 minus 1. So minus 2. Then K. So this will be 2 minus 2, 4. Okay. Let's cross verify it. So I we are going to solve this. So this will be minus 6 minus 2 minus 8. Okay, done. Then j, we are going to solve these. So 3 multiplied by 1 minus 2. Okay, done. And final, this k. So k will be minus 2. K will be 2 plus 2, 4. You got DRs minus 8, minus 2 and 4. I have already told you in previous class that we can have infinite DRs till the ratio is same. Okay, ratio of all three components should be same. So I can write these DRs in simplified term also, that we can divide it by minus 2. So this will be 4, 1 or minus 2. Now you have to find DCs. In previous lecture, I have already told you that there may be infinite DRs with having same ratio, but there will be unique direction cosine. Direction cosine will be what? You can take unit vector of this or unit vector of this. You will get same answer. Okay. So what will be the unit vector? DCs will be 4, 1, minus 2 divides by mod of 4, 1, minus 2. This will be what? This will be 4, 1, minus 2, 4, 1, minus 2 and under root of 16 plus 1 plus 4. So that will be given to you that 4, 1, minus 2, 1 by root 21. Now, someone asked me that this will be DCs for the line perpendicular to that. Yes, correct. But I am getting minus here. So let's say this was your L1, this was your L2. Okay. Whatever the ratios I have found, let's assume that this is outside the board. Okay, this is outside the board. So outside the board, this will be perpendicular to the L1 and L2. And can I say oppositely direction inside the board? That will be also L1 and L2. So if someone is getting minus, that is also true. So we can write plus minus. This will be DCs of vector perpendicular to the L1 and L2. Okay. Whatever the option is given in the question, you can tick that. Okay. Next, symmetrical form of line. Even though in previous lecture we have already seen it with the help of vector equation, we have converted into Cartesian form. But today we are going to see it with other way. So first, one point line passing from x1, y1. This point is given. The line is passing from here. x1, y1 and z1. And in direction of let's say it is vector b, and we can write it like this. Not vector b, let's say vector p, because I am going to write it ABC. Vector p, or you can write it like this, that A, B, C. ABC are, this is AI cap plus BJ cap plus CK cap. So what will be the equation of line? So first we are going to understand what is the geometry. Let's say this is the point from where line is passing. So x1, y1 and z1. And again assume that this is the point, let's say this is A and this is R. This is the point R which represents the whole line x, y, z. Now what? We have to find the equation of this line. Now what you can do? We can write like this, that there is a vector P, A, B, C. Line is in the direction of what? This vector P. So we can write that AR is parallel to vector P, vector AR. Yes or no? So you can write that AR vector is lambda times vector P. So this is similar as what we have done in vector form. But as we know that if two vectors are parallel, if two vectors are parallel, this we have already done. If two vectors are parallel, then A1 upon B1 should be equal to A2 upon B2 should be equal to A3 upon B3. Means ratio of their corresponding components should be constant. So we are going to do that. First, AR vector is what? AR vector is x minus x1, comma, y minus y1, comma, z minus z1. This is your x vector. And what was the p vector? This was your AR vector. That what was the p vector? That was vector A, dot vector A comma, B comma, C. These are the DRs of vector P. So, AR vector and vector P are parallel. Then, what you can write? AR vector is parallel to vector P. That means what I can write? We can write ratio x minus x1 divided by A is equal to y minus y1 divided by B is equal to z minus z1 divided by C. So, this will be your equation of line in symmetric form, or you can say this is an Cartesian form. Okay, we are not going to use Cartesian word because there are two forms Cartesian form. Okay, so next, what if 2 points are given? What if line passing through 2 points are given? Let's say x1, y1, z1 and x2, y2 and z2. Now vector is not given. So what we will do? Again, same thing. Even though vector is not given, we can find a vector. So this is your point A, x1, y1, z1. This is your vector B, point B, x2, y2, z2. And you can write any point R which represents the whole line x comma y comma z. Now what we can write? We can write first AB vector. What will be the AB vector? This will be x2 minus x1, comma y2 minus y1, comma z2 minus z1. This will be your AB vector. Now what? AB vector and that is AR vector that we have found out previously. This will be x minus x1, comma y minus y1, comma z minus z1. Again, what you can write? That AR vector is parallel to AB vector. If this is true, then ratio should be constant. So ratio will be x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. So this will be equation of line in how many points are given? When line is passing through 2 points. Okay. So this will be unsymmetric form of line. One more thing. What I told you in the start, that vector P, it is given A, B, C, where A, B, C are DRs. What? DRs of line in x comma y comma z direction respectively. Okay, these are in x, y, z direction respectively. But what if you have given DCs of line? Kya given ho? DCs of line. That will be L comma M comma N. So as simple as that, you have already written that L is proportional to A, M is proportional to A, and N is proportional to not A, M is proportional to B, and N is proportional to C. And when we are removing proportionality constant, we have same constant. So L is K times A, M is K times B, and N is K times C. I have already shown you that relation between A, B, C and N. What you could have done at that time? That L square plus M square plus N square is equal to 1. And after putting that, you can remove the K. But we don't need that. What was the equation of line in DR form? X minus x1 upon A, y minus y1 upon A, B, and z minus z1 upon C. So what you can do? You can multiply by K. Denominator, you can multiply by K in all three sides. So what? It will convert into L, it will convert into M, and it will convert into N. So what will be the new equation? X minus x1 divides by L, y minus y1 divides by N, z minus z1, L, M. So this will be M and this will be N. So this is equation of line passing through a point and whose direction cosines are LMN. Okay. Let's see shortest distance between two lines. First of all, I have to define three conditions, because in 3D we have three conditions of line. What are those conditions? First, two lines may be intersecting, two lines may be parallel, and then two lines are maybe what? Skew lines. Two lines are maybe skew lines, means first intersecting, like my elbows are joining, okay, then parallel, and then we can means take an angle between those lines. Now these lines are neither parallel nor intersecting. So this is one more method which helps you that whether line are intersecting or not. Okay, so first of all, if lines are intersecting, so what is the shortest distance between intersecting lines? Obviously 0. Why? Because they are intersecting at the same point, and at that point the distance between both lines will be 0. So shortest distance, in that case, shortest distance, let's say SD, this will be 0. Dusra, second point, if L1 is parallel to L2, two lines hai, we have two lines and both lines are parallel. So it is not like that we have not done this. This is your L1. Okay, I hope this is visible, and this is your L2. Both lines are parallel. Both are passing through some points. Let's say this point is your x1. Let's say vector A. We will write it in vector form. Let's say this is vector A. This is passing through vector B. Okay, and this is your distance. This is what? This is your distance. And what? You can give equation of L1 as vector R is equal to vector A plus lambda times vector B, not B, Q. And L2 can be given like this, vector R is equal to vector B plus lambda times mu times vector Q. Why vector Q? Because both lines are parallel, then direction will be same. Now what we can do? We can do that this is your distance and this is your AB vector. There are two ways. First, you can find? You can find foot of perpendicular of this. Method 1. Find foot of perpendicular of vector A on L2. As soon as you can find foot of perpendicular of vector A on L2, you can directly find the distance. How? Let's say this is your A and this is your N. Then AN will be distance from A. AN distance will be from A to the line to L2. And because both lines are parallel, so this will be perpendicular distance. So distance will be constant. Another method, M2. What is another method? So another method will be that, what is this angle? Okay, so let's say this is your AB vector, A vector, B vector. Okay, and this was your distance. This was your D. You have to find this. Okay, and this vector is given to you. This is vector Q. Okay, so let's say the angle between AB and B, this is theta. This angle is theta. So according to this D will be nothing. D will be, this point is A, this point is B. We are going to remove vector A and vector B. We will use it whenever it is required. Remove those. Okay, so this will be your vector A, B. So D will be AB sin theta. D will be AB sin theta. Now, how can you find sin theta? So let's say this is your AB vector and angle in between them is theta. So what we can write? Mod of AB cross this vector q, because we already know q. Mod of AB cross q will be mod AB mod q sin theta. This will be the value. So what will be the value of sin theta, or let's say mod AB sin theta? Mod AB sin theta. What will be the value of this? This will be AB cross q mod divides by mod. Okay, so as simple as that, you can put this in this formula. So shorter distance D will be AB cross q divides by mod q, and there is a mod above it. Okay, so this will be shortest distance between parallel lines. Okay, what is AB vector? AB vector will be B vector minus A vector. What was the vector B? Vector B was the position vector of the point which is passing through what? Second line. Second line is passing through. Okay, what is A vector? A vector is a point from where first line is passing. Vector Q. Vector Q is drs of, let's say, L1. Why? Because drs of L1 and L2 are same. Why? Both are parallel. So as simple as that. Now problem starts from here. What if lines are this? These are two different planes. You can take two copies, put it like this, and you can rotate this. One line is in another plane, another is another. Means, I mean to say that both lines are neither intersecting nor parallel. That means what? Skew lines. Skew lines. Both lines are skew lines. Then what we can do? So let's think it simply. What we can do? So again, I have to show it to you by the hands. There are two ways you can do it. First, I will show you proper method. What if you forget the formula? What we can do? In that case, we will use completely geometry. So now, these are my two hands. You can easily see it. What will be the shortest distance? Shortest distance should be the line perpendicular to this hand and line perpendicular to this hand. So what we can do? We can join two hands like this. And if I extend again, so whatever the point was there, like this span. So the line perpendicular to the both hands will be the shortest distance. Now, what we can do in this thing? This is your line L. We call it L1. We will call it L1, or maybe they are writing as L. And another line, that is, let's call it L2. L1 is passing through A. So equation of L1 will be vector R, vector A plus lambda times vector P. And equation of L2 passing through vector B and direction is vector Q. So equation will be vector B, equation will be L2. That will be vector R, vector B plus lambda times vector P. This will be vector Q. Okay. So these are equation of line. Remember, P and Q are not parallel, neither they are intersecting. So these lines are neither intersecting nor parallel. So we are solving skew lines. So we have to think about it. So as I have already told you that shorter distance between two skew lines must be the shortest distance, the part of the line which is perpendicular to the both lines. So now we can see there is a line LM. So this is perpendicular on L1 at L and perpendicular at M. So LM will be the shortest distance between those two lines. So what we can do? We have already studied this concept. What was the concept? We can find vector projection of AB on LM. See, like this. AB is this and LM is like this. This LM is perpendicular to what? This LM is perpendicular to the both line L1 and L2. So LM is perpendicular to L1 and L2. Okay. So now what we can do, as we are studying free vector. So what we can do, we can take this vector, superimpose it with this m vector. Okay. Now the point B and point M are same, even though they are different points in the plane or line. But what we are doing as a vector, what we did, we joined M and B. So what we can do, see, this was your line and this was your perpendicular on this. So what is LM? LM is nothing that is projection of AB, vector AB on LM vector. Okay, this is projection of AB on LM vector. So what was the projection of AB on LM vector? This will be AB vector dot. This will be AB vector dot LM cap, if you remember that. So this will be what? AB vector dot LM vector divides by mod LM vector. Now the thing is, we have to just find LM vector. So again, what I have written here, that LM is perpendicular to L1 and L2. How you give any vector perpendicular to L1 and L2? In previous lectures, we have already studied in the property of cross product, that if we have to assume any vector perpendicular to the two vectors, we assume it lambda times something. So LM vector will be lambda times, what are the direction of this, P or Q? So someone says, sir, can we take P cross Q? Yes, you can take P cross Q. And someone says, can we take Q cross P? Yes, again, you can take Q cross P. It doesn't matter whatever you are taking. So lambda times P cross Q. What will be LM cap? Or leave it, you can put this value here. So this will be AB dot LM. LM is P cross Q, not P cross Q, lambda times P cross Q. Similarly, mod of lambda times P cross Q, that will be magnitude of P cross Q. So we can take lambda outside and lambda will be cancel out. So this will be AB dot P cross Q divides by magnitude of P cross Q. Okay, so what we can do, we can take one more mode outside. Why? Because we are finding distance. So this vector might be negative, so we are putting mod. So this is shortest distance between skew lines. Now, this is a very important concept. Why? Because whenever we are going to solve question, we will directly see that line are parallel or not. If they are not parallel, we will assume skew lines. See, in the start, when we are solving the nature of lines, what we were saying? First, we were checking whether the lines are parallel or not. Okay? If lines were parallel, then we were proceeding for the parallel portion. And if they were not, we were directly assuming those lines as intersecting. We were assuming those lines as intersecting. That's why we were putting the coordinates of L1 is equal to coordinates of L2, corresponding coordinates. In this case, we were by default assuming that two lines are skew lines. If shortest distance between them is 0, then again, these were two hands. Okay, perpendicular line was there. If shortest distance is 0, that means these two hands are joined together, right? So this means these two hands are intersecting with each other. Got it? So let's see if we have any question. Okay, let's assume there are two lines, L1, vector R, that is 1, 2, 3 plus lambda times 2, 2, 1. And next L2, vector R, 0, 0, 1. I am taking random lines, okay, plus mu times 1, 2, 2. Okay, these lines may be intersecting or not. How we are going to find that? We will directly find shortest distance, or you can do all the calculation like that. So what we can do? So we will directly write, because in the question, the only thing is asked whether lines are intersecting or not. Okay. So first method we have already studied, that what we have to do? We have to find that 1 plus lambda 2 is equal to 0 plus mu. Then 2 plus 2 times lambda is equal to 0 plus 2 times lambda, and 3 plus lambda is equal to 1 plus 2 lambda. We can solve any two equation and we can see by the third equation whether the line are intersecting or not. Parallel line, these are parallel lines or not? How can we see that? So these two vectors are not parallel. If these two vectors are not parallel, then these two lines are not parallel. So what we can do? Shortest distance. So first, to find shortest distance, we have to find some things. Okay, first we will write the formula. That will be AB vector dot P cross Q divides by P cross Q. So mod and complete mod. So first write A, vector A, vector B, vector P, and vector Q. Vector A will be 1, 2, 3. This will be 0, 0, 1. And vector P will be 2, 2, 1. Vector Q will be 1, 2, 2. Okay. So 1, 2, 2. Okay. So what will be AB vector? AB vector will be, okay, I can directly see that these lines are intersecting, but okay. AB vector will be B vector minus A vector. So minus 1, minus 2, and 1 minus 3, minus 2. What will be vector P cross Q? P cross Q will be I, J, K. 2, 2, 1, 1, 2, 2. So first I. So 2, 2, 1. 4 minus 2, that will be 2. J. 4 minus 1, that will minus 3. Okay. Then we can find that 1 last K. So 2, 4 minus 2, again 2. Okay. So now we can find that AB dot, and again we need mod P cross Q also. Mod P cross Q. So mod P cross Q will be 4 plus 9 plus 4. That will be root 17. So now again, what was the shortest distance? Shortest distance was AB dot P cross Q divides by mod P cross Q and whole mod. So what was the value of AB? AB was minus 1, minus 2, minus 1, minus 1, minus 2, minus 1, minus 2. Dot. This will be 2, minus 3, and 2 divides by root 17, and we can take whole mod. So minus 1 multiplied by 2, that will give you minus 2, minus 2 multiplied by minus 3, that will give you plus 6, and minus 2 multiplied by 2, that will give you minus 4 divided by root 17. So you got distance 0. So if shortest distance between two lines is 0, then both are intersecting lines. Okay. What was the method to find shortest distance between two lines? So what you can do, I am creating skew lines. Okay. This is your yellow line. This is your white line. These are not intersecting each other. So now you have to find one line, let's say red color one, which is perpendicular to the both. Okay. So let's say this is again L, this is your M. This is perpendicular to the both. What you can do? What is the equation of L1? Equation of L1 will be vector R, let's say x1, comma y1, comma z1 plus lambda times, we have a1, a2, a3. Okay. So we are talking about 1, 1, 1. So we will write it 1, 1, 1 in case of this. A1, B1 and C1. Then L2. This will be vector R, x2, y2, z2 plus mu times a2, B2, C2. These are your two lines. So how we are going to find it? By calculation method, not this vector form. So what we can do? Yes, we have to use some concept of vector also. So what is the coordinates of L? Coordinates of L will be general coordinates of L1. So this will be x1 plus lambda times a1, y1, we can write it like this, coordinate of L, x1 plus lambda times a1, y1 plus lambda times b1, z1 plus lambda times c1. These are your coordinates of L. Okay. Then what are the coordinates of M? Coordinates of M will be x2 plus mu times a2, फिर y2 plus mu times b2 and z2 plus mu times c2. So what you can find? You can find first what will be the LM vector. As soon as you are finding LM vector, now second, LM vector dot A1, B1, C1, that will be 0. Why? Because L1 is perpendicular to the LM. And second, third step, LM vector dot A2, B2, C2, that is also 0. Why? Because again this is perpendicular to L2. Then you can find two equations in lambda and mu. So you can solve lambda and mu. As soon as you are finding lambda and mu, you can find L and you can find M. So as soon as you are getting L and M as a coordinates, so what will be the distance? You can use distance formula. Okay, this is the long process. The next is plane. What is the plane? Okay, so simple definition of plane is given by some scientists to layman terms, that if you are writing a line, means if you are drawing a line, okay, plane is a surface on which you can draw a line completely and it should be the part of that surface completely. So this is plane. This is plane. And you have seen, I think, some teen shades. Teen shades are like this. Okay. If you draw a line is a straight line. This is also line, but I'm talking about the straight line in 3D. If you draw a line, so only some points are on that surface, not complete line. On the other hand, if I have a plane, let's say one page of your copy, if you are drawing a line on it, line means shortest distance between 2 points, that is line. So if you are drawing a line and line is completely on that surface, then that will be a plane. So how are we supposed to find a plane? So it is a very simple. There are two major components of a plane. Again, to find equation of anything, you need at least two information. That I am saying, that at least two information you need. Maybe you need more, but at least two is required. So now let's say this is your plane. When I am drawing plane like this, it doesn't mean that we have finite plane. So this is extending in infinite direction in this direction, this direction, this direction, and also this direction. Now, whenever we are talking about the components of plane, we need two things again. One, the direction of plane. Now, this is very subtle topic, that what is the direction of plane? So now, if you are assuming, let's say, any line in the plane, let's say you have assumed this vector. Let's say, sir, this is the direction of plane. Again, someone says, no, I can take this, I can take this, I can take this. These are infinite direction in a plane. Okay. So this cannot be counted as a direction of plane. So what we can do? So it doesn't matter whatever direction you are taking in a plane. We cannot count it. So what we can do? So new concept came here. That is concept of normal. So if I am putting a pen perpendicular to this vector. So if I am putting anything perpendicular to this screen, it doesn't matter whether it is inside or outside. This will be unique. It doesn't matter whether I am putting it here or here or here. These all are parallel vectors outside the board, right? So plane has two components. First, plane has a normal vector. plane as normal vector. And the second thing is, it passes through a point, means one information also required. First, if normal vector is given, then one information is also required, that it passes through some point. Let's say vector A. Okay, so let's make this plane a little big. There is a normal perpendicular to it, so I cannot show it in 3D, but let's say this is coming outside. So this is your n vector. Okay, this is your point vector A from which plane is passing. That is also done. And you can take any point R which represents the whole plane. What is R? R is always position vector of x, y, z. Okay, this is position vector of x, y, z. Now what? So this is your AR vector. What you can say, that AR vector lies in a plane and normal vector is perpendicular to the plane. So that is also perpendicular to this AR vector. So what we can say, let's say A and R. AR vector is perpendicular to the normal vector. AR vector is perpendicular to the normal vector. That means AR dot n must be 0. AR dot n must be 0. What will be AR vector? R vector minus A vector dot n vector equal to 0. So what happens? R vector dot n vector is equal to A vector dot n vector. This is your equation of plane. But in some textbooks, because A dot n is a scalar, A is known, n is known. So A dot n will be known, R is unknown. Okay. So in some textbooks, they are writing it like this: R dot n is equal to D. So this is your plane of equation of plane. For example, if let's say it is written like this: R dot 3, 4, 5 is equal to 6. So this is your A dot n and this is your normal vector 3, 4, 5. Okay, it may be lambda times normal vector, because if you are writing lambda here and lambda here, it will get cancelled out. Okay, so now what you got? Planes equation. We got R dot n equal to vector D, not vector D, D is a scalar. What was R? R was x, y, z. What was n vector? Let's say it is ABC. And let's say capital A, capital B, capital C. Capital B, capital C. Okay, what is ABC? ABC are DRs of normal vector of plane. So now put the values. So what you get? X, Y, Z dot A, B, C equal to small d. So that will be AX plus BY plus CZ equal to D. So what we can do, we can take D this side and we can put AX plus BY plus CZ. We can replace it by capital D. So this is your equation of plane equal to 0. Where capital D is nothing, that is equal to minus small d. What was small d? Small d was A dot n cap, n vector. Okay, just remember this. So this is equation of plane in Cartesian form. This is equation of plane in Cartesian form. Okay, next part. Now, these are the conditions given. That line given hai, L1, L2 are given, plane 1 and plane 2 are given. Then we have to find condition if L1 is parallel to L2. These are all previous conditions. Okay, first we will see L1 is parallel to L2. If L1 is parallel to L2, then 100% direction of L1 and L2 are also parallel. So what we can do, we can write vector P is parallel to vector Q. So vector P is equal to K times vector Q. The end. This is your condition of when two lines are parallel. Second, it has asked that L1 perpendicular to L2. L1 perpendicular to L2. That means straightforward, P dot Q equal to 0. Third one, it has asked that P1 is parallel to P2. Now you have to understand P1 is parallel to P2, what means? That this is one plane, this is another plane. Okay, this is the normal of plane 1. This is a normal of plane 2. If two planes are parallel, then their perpendicular lines are also parallel. So it says that P1 is parallel to P2. So straightforward, you can write that N1 vector is equal to again K times N2 vector. Now this K is different from that K. Okay, N1 vector is equal to K times vector 2. Fourth will be what it is, that P1 is perpendicular to P2. Again, now you can take these two walls. These two walls are perpendicular to each other. So their normal vectors are also perpendicular to each other. So P1 is perpendicular to P2. What you can write? N1 vector dot N2 vector equal to 0. So straightforward, you can understand that I can show it by like this line. So this is your plane 1, this is your plane 2. This is perpendicular to this and this is perpendicular to this. These planes are perpendicular to each other. And if I draw normal of this and normal of this, again, normals are perpendicular to each other. Please remember this. This is going to useful concept in angle between lines and plane. Fifth. What fifth says? Fifth says that P1 is L1 is perpendicular to P1. Okay. This was your plane. First you will write the condition that L1 is perpendicular to P1. This is your plane. This is your normal N1 vector. And this is your line, which is also perpendicular, L1. The direction of line is given by vector P. So vector P or N1 are parallel. So what you can write? That vector P is parallel to vector N. So vector P is equal to, this time I will write in K1, vector N. Okay, K times vector N. So direction of line L1 and normal of plane 1 are parallel. Sixth. What sixth says? In sixth point, it says that L1 is parallel to P1. Now you have to understand something. When it says L1 is parallel to P1, so this is your plane. So if one line has to be parallel to the plane, it will be like this. Or just create one more plane parallel to this plane, or you can draw any line in that plane. You can understand it by this, that this is your floor and that is your roof. Draw any line on the roof, this will be always parallel to the floor. Okay, this will always be parallel to the floor. Now, any perpendicular to the floor will be perpendicular to the roof and perpendicular to that line. So this is your L1, this is your P1. If I draw a normal will be perpendicular to the L1. So what you can write, that P dot, that P represents direction of L1 dot N1 equal to 0. Okay. Then again, these are 6 conditions. Then which is next condition? Next condition is that done. 6 done. 7th, L1 is perpendicular to the P1, and these are same. L1 is perpendicular to the P1. What is the use? So 7th and 5th are same. Next is 8th, L1 contained in P1. L1 contained in P1. So what we can write? Okay. 8th. Now you have to visualize something. I am creating a big plane. My plane is always big. It is a size of infinity. And this is your one line, L1. L1 is passing through point A. Okay. And direction of L1 will be vector P. On other hand, direction of plane is not defined, but normal of plane is defined, vector N. So first thing, what you can write, that vector N dot vector P. This will be what? 0. Vector n dot vector p will be 0. Second, but if you are writing only this, that vector n dot vector p will be 0. So what is the difference between this case and the last case where you were writing that L1 is parallel to P1? L1 is parallel to P1. What is the difference between these cases? So what was the equation of this first plane? So equation was, I guess, R dot N1 is equal to D1. This was your equation of first plane. Now again, the plane is also passing through this point. So this point will satisfy this equation. So you can put vector A here. So this is A dot N1 is equal to D1. Okay. So there are two conditions. That line is contained by this plane. So these are the 7 or 8 conditions I have already told you. And I have some questions based on that. So please, you can note these questions and try to solve these. Okay. Or you can take a screenshot of this. Try to solve this. We are going to solve these questions in next class, in next lecture. Okay. So now next is other forms of equations of plane. Okay. So what equation we have seen? First, vector form. We have seen vector form. This was what? Clearly R dot N is equal to D. Second, we have seen Cartesian form. Which was what? Ax plus by plus cz plus d equal to 0. Where a comma b comma c are what? drs of normal. Sometimes what happen? We are not given drs, or let's say we are given drs, but we have to find the equation of plane. So how you are going to find the value of d? So one point is also given, x1. So what you will do? You will put x1, y1, z1. So what is the value of d? Value of d will be minus ax1 minus by1 minus cz1. So another equation of this, ax minus x1 plus b y minus y1 plus c z minus z1 equal to 0. Okay, this is the equation of plane whose normal vector has drs abc and passing through x1, y1, z1. Okay, so now is third part. Third part is parametric form. Parametric form. What is parametric form? In this type, the plane equation of plane is not given. In this case, the equation of lines, equation of plane containing L1 and L2 is given by. Okay, first you can write L1. L1 will be vector R, vector A plus T times vector P. And L2, vector R is equal to vector B plus, again we can write vector A. So this will be vector A plus S times vector Q, where T and S are parameters. So what is the equation of plane? First, you have to write vector R. Vector R represents all the points on the plane. Okay? Then point of intersection, vector A, you have to write. Then lambda times vector P plus mu times vector Q. What is this? This thing you have already studied in 11th class, family of line. You remember L1 plus lambda L2. So L1 plus lambda L2 represents all the line passing through the point of intersection of L1 and L2. And if you remove those lines, you can create a plane. But this is in 3D. So now you have to convert this equation into plane. So what will be the normal vector? Normal vector will be that this is the equation. What is the vector A? Vector A represents point of intersection of L1 and L2. Let's say in this question I have taken both lines are passing from vector A. So we can observe that both lines are intersecting at vector A. But what if it was not given? So you would have find the point of intersection of L1 and L2 and direction of line 1 is vector P and vector Q. Both lines contained by a plane. Let's say again, take a floor. Draw any two lines passing through a point. Okay, these two lines are not parallel. So now, how you are going to give a normal vector? So normal vector will be simply vector P cross vector Q. So if you have to convert this line in vector form, so that will be what? Vector R dot P cross Q and is equal to vector R instead of that A dot N. So A dot P cross Q. As simple as that. So this is your equation of plane. The above equation, this equation is known as parametric form. Okay. Fourth form. Now this form is exactly same as form of line in 2D. So this is known as intercept form. Intercept form. What was the intercept form of a line in 2D? That was x upon a plus y upon b is equal to 1. Similarly, this is x upon a plus y upon b plus z upon c is equal to 1. This is what? This is intercept form of plane. So where a is x-intercept. Again, you have to remember this is the standard form that you have to write right side 1 and in left side coefficient of x should be 1 and everything should be in denominator. Coefficient of y should be plus 1 and everything should be in denominator. Okay, coefficient of z should be plus 1 and everything should be in denominator. That is your intercept form, x-intercept. Similarly, b is y-intercept and c is z-intercept. Okay, so what? Now, distance of a point from a plane. For right now, you can directly remember this. So, the formula is very simple. I can even derive it, but it will take a little bit time. So, in this lecture, we are not going to derive it. We will derive it in next lecture. So, this will be what? You can remember it directly. Ax1. So, we were writing capital A. So, let's say this is your plane. I am writing this plane in Cartesian form. That is Ax plus By plus Cz plus D equal to 0. In some textbooks, these are written as small a, small b, small c and small d. And this is your point. Let's say x1, comma y1, comma z1. You have to find distance from here. So, now I have already told you the process, what you can do. Okay? What you can do? This is your plane. A, B, C and D are known. This is your x1, y1, z1. This is known. So what you can do, method 1. You can find, let's say this is point, this is your B. You can find foot of perpendicular of A. And this is useful. Why this is useful? So we can find image also. So how you are going to find foot of perpendicular of A? You can find equation of what? Equation of line AB. Equation of line will be AB what? So you required one point and one direction. Direction will be this and vector. So what will be the equation of line? X minus x1 divides by capital A, y minus y1 divides by capital B, z minus z1 divides by capital C, and you can assume equal to lambda. So what will be the value of x comma y comma z? This will be a lambda plus x1, b lambda B lambda plus y1 and C lambda plus z1. And you can put in plane and get lambda. As soon as you are getting lambda, you can get coordinates of B. These are coordinates of B. And as soon as you are getting B, you got foot of perpendicular. You got foot of perpendicular, then you can find AB. Then another method, method 2. And we are going to remember the formula. Method 2 will be directly D is equal to AX1 plus BY1 plus CZ1 plus capital D divides by under root of A square plus B square plus C square. This formula is exactly same formula as the straight line in 2D. AX1 plus BY1 plus C divides by under root of A square plus B square. Exactly same formula. So again now, distance between the parallel planes. Distance between the parallel planes. So these two planes are parallel. If planes are parallel, then their normals are also same. Even though we have one more formula that is in vector form, we are always going to remember the formula in Cartesian form. That is the best. So equation of this plane will be AX plus BY plus CZ plus D1 equal to 0. And equation of this plane will be AX plus BY plus CZ plus D2 equal to 0. Okay? Please remember this formula. D2 equal to 0. Now what? So these are two parallel planes. How you do know that these are parallel planes? Because we have same DRs for normal. So what we can do? So this will be distance between two planes. Again, I have already told you the plane in 3D behaves exactly same as line in 2D. What was the distance between two lines? Parallel lines. So distance was directly C1 minus C2. So here it will be D1 minus D2 divides by under root of A square plus B square plus C square. As simple as that. This is distance between those two parallel planes. Okay? So we can easily find the distance between two parallel planes and distance of a point from a plane. I have given you two methods. First method is also important. Why? Because you can find foot of perpendicular from that. So we are going to study foot of perpendicular and image also in next class. So next, there is one more thing, angle. Angle. First, angle between two planes. Let's say first plane is vector R, N1 vector is equal to D1, and second plane R, N2 vector is equal to D2. To find angle, it is very best choice to always write vector form, or you can do by Cartesian also, because in that Cartesian form you can easily say that coefficient of x, y, z are nothing, those are drs of normal vector of plane. So now this is your plane 1, this is your plane 2. Let me create those two planes, but yeah, again I will represent those planes by line, because they are, this plane is going infinite. Again, these two planes are perpendicularly inside this screen. Now what? Now we have two normals. So this is the normal of this plane and this is the normal of this plane. So if this is the angle theta between the planes, what this angle will be? So this is 90 degree, this is 90 degree. We have quadrilateral. In a quadrilateral, sum of all the angles will be 360. So 90, 90, 180. So this will be pi minus theta. Okay, this will be pi minus theta. So whatever the angle you are finding between this is also pi minus theta. Okay, so angle between two planes is either theta or pi minus theta. So what is the, and this is your n vector. This is also n vector. Again, if I extend this is also theta. This is n1 vector. Oh, not this is n1. This is n2 vector and this is n1 vector. This is normal of first plane. This is normal of second plane. So if we have two vectors, okay, you can assume any direction, it doesn't matter. So let's say I am taking this direction. So this is pi minus theta and this was your theta. So this was your n2 vector and this was your n1 vector. What is the angle between n1 and n2 vector? So this will be cos pi minus theta is equal to n1 vector dot n2 vector divides by mod n1 vector n2 vector. As simple as that. So angle will be cos pi minus theta is equal to n1 vector dot n2 vector divides by mod of n1 mod of n2. Similarly, in the line we used to find acute angle between them, not obtuse angle. So whatever you are getting, you will always find theta as acute angle. If you are finding acute angle, so what you will do? You will take mod of both sides. Cos pi minus theta is equal to mod of n1 dot n2 divides by mod n1 mod n2. Why? Because we have to always find acute angle. So cos pi minus theta is minus cos theta, but minus will be positive and cos theta is always positive. Why? Because theta is acute angle. So you will get formula cos theta is equal to n1 vector dot n2 vector divides by mod of n1 vector n2 vector. Okay, as simple as that. This is angle between two planes. What if we have to find second one? Angle between line and plane. You have to be careful in that case. Angle between line and plane. Okay, in this case you have to be careful. Why? Let's say this is your plane, this is your normal vector, okay, and this red line is your line. So you have to find, again this is also 90 degree. Why? Because this dotted line is inside the plane. Why? Okay, this is your angle theta. So there are two angles. One is theta, one is pi minus theta, another side. Okay, you have to find this theta. Now you don't know the direction, any direction in the plane, but you know the normal direction of this. So this is pi minus theta, and let's say the red line's equation is L vector A plus vector R is equal to vector A plus lambda times vector B. Okay, so instead of writing B, I will write it P because we are generally writing it as P. And what is this? This is normal vector N. So we know two vectors. One is direction of line, one is normal of this. So this will be angle between these. So let's say cos phi. Right now I am writing phi because angle between these is pi minus theta. So directly write it as pi by 2, not pi. This will be pi by 2 minus theta. Let's remove it, call it phi. We will call it phi. So this will be cos phi is equal to, what will be the angle? Angle will be vector A dot vector P divided by mod A mod P. Because we are talking about what? Which angle? Acute angle, so we will take a mod. So now again, you can see from here that this is 90 degree angle, this is theta and this is phi. So theta plus phi must be 90 degree. So this gets converted into sin theta is equal to mod of A. Why are we writing A? Okay, so this is wrong. It's not A because you are finding angle between normal vector and you are finding normal. So let's clarify it first. So angle between line and plane will be same as, it will be same as angle between vector P, which represents the line, and n vector, which represents the normal of this vector. So this will be cos phi is equal to vector P dot vector n divides by mod P mod n. Okay, that is done. That is good thing. Okay, now we know theta plus phi is equal to 90 degree. So we have to put the value there. So this will be cos pi by 2 minus theta, because angle between line and plane we have to find. We don't have to find angle between normal vector and the line. So this will be what? It was vector P dot n vector divides by mod vector P mod n vector. Okay, so this will be sin theta equal to mod vector P dot n vector divides by mod vector P n vector mod. So this will be angle between line and plane. Okay, so in next class we will see some more topics related to plane. I have given you one question, we will solve that question also, and I have told you that we will see derivation between point and a line in vector form also at that time. Not point and line, point and plane. Okay, so thank you.